Physics, part 85. Calculate the time taken to heat the water from 15 degrees Celsius to 100 degrees Celsius. The kettle is left switched on when the water temperature reaches 100 degrees Celsius. Calculate the rate at which the water is boiled away. The specific latent heat vaporization of the water is 2.26 mJ kilogram. D. The kettle in C is used 6 times each day to boil water. On each occasion, approximately 200 gram excess water is heated. Given that 1 kilowatt per hour of energy costs 6.5 cents, estimate the extra cost involved each year. An electric heater, number 4. An electric heater in some water of mass 700 gram. The heater is switched on and the variation with time of T of the temperature theta of the water is shown in the figure. A, one given that the specific heat capacity of water is 4,200 joule kilogram. Determine the power of the heater. State 2 assumptions made in your calculation. B, the heater is then removed from the water and is placed in a hole in a block of metal of mass 1.2 kilogram. The heater is switched on and readings of temperature theta and time t are taken. These are also shown on figure. Determine the specific capacity of the metal. Suggest why the experiment would not be suitable for the determination of the specific heat capacity of an insulator such as concrete. Now we've got chapter number 5, that is force and collisions. Well, in the previous chapter we described motion in terms of displacement, that was chapter number 3, velocity and acceleration. Now we will try to explain why bodies move. We shall realize that a force is required to make a body accelerate. This will introduce Newton's 3 laws of motion, the fundamental laws which state and define what forces do in relation to motion. We shall then see how Newton's laws help us to explain what happens in collisions, which are important in many areas of physics. The total momentum of a system of colliding bodies remains constant. This leads us to the principle of conservation of momentum, one of the important conservation laws of physics. 5.1 is force. At the end of 5.1 to 5.4, we should be able to show a qualitative understanding of the frictional forces and viscous forces, including air resistance. We should be able to state each of the Newton's law of motion. We should be able to recall and solve problems using the relationship F is equal to ma, appreciating that acceleration and forces are always in the same direction. We shall be able to show an understanding that mass is the property of a body which resists changes in motion. We should be able to describe and use the concept of weight as the effect of gravitational field on a mass. We should be able to show an understanding of the effects of fields of force as exemplified by the forces on mass charge in uniform gravitational and electric fields respectively. We'll explain more about force and talk more about collisions in next videos.